Hello again, folks, in 114. Today we're going to be covering section 4.1. Let me begin. Normally, what I would do if we were in person is I would make you a packet like this of several diagrams that I've made to help explain the topic for the day. Anyhow, what I'm going to do is I want to show you where to look for it on the Canvas course page. This will cooperate, so that you have access to this material. You have the entire semester's worth of diagrams at your disposal. You could print any one at any moment that you want. But this is what is relevant to today's subject 4.1. Okay, and it consists of these pages. There's an overview diagram. We're going to be talking about systems of numeration. And I put a little space always if you want to annotate, fill in any additional information. There's this diagram that I've made. When we have terminology, it is sometimes easiest to get going by just analyzing the vocabulary, right? And often math is a symbol to abbreviate. So we have a concept, you have a symbol to abbreviate, and then you briefly describe what it is, okay? In this case, it will be the difference between numbers and numerals, which we think of synonymously, right? This is very useful. I swiped this from the textbook. It's an overview of the different number systems, the unique characters, right, including the Egyptian hieroglyphics, the Chinese, traditional Chinese characters, Roman numerals, and the ciphered Greek system, okay? And then I made 4 pages, somewhat as a worksheet. We'll fill this in together as I'm talking, to describe the key points about, firstly, Egyptian hieroglyphics, then Roman numerals, and traditional Chinese, and lastly, Ionic Greek. Those are the systems for today that comprise section 4.1. These are the examples that you would have in the in the textbook, whether you have the ebook version or not. All right. Anyhow, I included the solutions for these because, perhaps you would rather look at this than listen to me. Anyhow, that's fine. I'm going to go through these so that you have some frame of reference, right? But I'll always have that available to you, the examples from the book printed. This is all as a PDF, so you can print those pages. All right, let me put this aside. And as I mentioned, I'll show you where to look for these in our Canvas course tile. I have to adjust the camera, it looks like. Okay. Now it's not too egregious, right? I don't think that's bad. Maybe a tad further back. This doesn't really slide very well, I gotta say. The lens focus. Yeah, it's not particularly cooperative. Alright, well, it's not getting any bigger. Alright. This is the keystone, which I might just leave it like that. Alright. It's not really an improvement, unfortunately. You know what? Let me see if I can just rotate the feet. That's a little bit better. Alright. Enough futzing with it here. I'm sorry, I have to do this every time just because it's on a cart in my kitchen. And I can't eat in here if my camera is all set up. Such is life in Corona world, right? Alright. That's probably as good as it's gonna get. What do you want for $5? No, I got that from, it was $50, that camera from, I believe it was Kodak. Alright, anyhow, if you are looking to print, as I mentioned, these pages relevant to section 4.1. Actually, let me just adjust the camera a wee bit here. That's good. Okay. If you're looking to print these pages for your own purposes, right, they're always going to be available. They're already available in pages, right, aptly named, right? And what you will see here is, since we're in chapter 4 is where we're starting, you'll see these documents all here. Okay. Systems of enumeration. There's the preview. I think it's going to be a little squashed because it's a preview rather than the full page. So I'm going to go back to my own files and just open it from there. But this is this document that I was just showing you. And this, I hope, is very useful. Facts about ancient systems, right? Since we're going to be dealing with 4, it's good to have some key information about each, right? That's written on these pages, which again you can print. Right? They're new as of last summer is when I made this. And there are the tables, and then here are the examples from the book. Right? Anything with these green sort of font and highlights. They're the examples I swiped from the book. I just cut and paste them into a Word document at one point. Well, it was PowerPoint, actually. All right, so you know where to look for them. All right, they're clustered together in color. So like when I posted this under pages, you notice that these were all red. Just assume that if they're all the same color, they're all the same section, right? And then I changed the color when we went to a different section. So it's not heading that's saying 4.1, 4.2, 4.3. But one could infer that, okay? All right. Now, you know what I really should have done is just remind you, why am I covering section 4.1 today? Because of the calendar, right? Which you could always see right on the front page of our Canvas course tile. I did the introduction last class for Monday, and now we're discussing for Wednesday's period, section 4.1, okay? Next week will be 4.2 and then 4.3 and so forth. The nice thing is that it's pretty much one section per day up until just after the spring recess. Section 7.1 and 7.2 I had a bunch together because we don't actually have that week, unfortunately. Okay, so look for those videos as we proceed. Okay. All right, now that's enough of that. Leave student view. And I'm going to just minimize this right now. Let us start with the vocabulary. No, I don't want to do that, sorry. Here's this sheet. All right. Just to get the vocabulary out of the way. There's only 3 phrases that you really need to be familiar with for this purpose. Right? There's a nice quotation, which it behooves me to cite, to give credit, right, from your book. I rather like it, because it gets at the heart of this. On page 164, there's this phrase, we think in a number. But we write a numeral. That is essentially the difference between these two concepts. All right. If you wanted it to be a little bit more formal, again, this is something you'd see me use a lot. I made this sort of scaffolding, and if you go into the profession of teaching, whatever subject, whether it be math, science, or history, right? There's always unique terminology. Give this to a kid. Give the student a blank piece of paper like this so they can collect the vocabulary. There is no easier task for somebody, and since it is relatively easy, they're a little bit more persuaded to listen to you, hopefully. All right, a number, all right, which could be any you could think of, is what we would refer to as a quantity, an amount, how many, quote unquote. Right. Whereas a numeral, this writes nice, I have to say, is the actual symbol. Very sloppily written, sorry. Is the actual numeral, the actual symbol to represent it. Okay. Now, being that we are in chapter 4, all right, and the title of the chapter is Systems of Numeration, it probably would be a good idea to sort of describe that. System of numeration. I'm a little short for the space because I'm writing on a projection, but humor me. All right, a system of numeration is I'm going to put this in fancy braces on purpose, a set. All right. Now, if you were in 113, you're familiar with discrete math and set notations, right? That gets covered normally in section 113, if not elsewhere. So it is a set in the formal definition of math, right? A set of what, though? Of the symbols, so therefore a set of numerals, right? All right. And also a scheme, which is a plan, for combining them. For combining these, right? So, having said that, acquainted with the vocabulary here, number, numeral, systems of numeration. All right, let's move on to an overview of the various systems of numeration we're going to discuss in chapter 4. Okay. All right, and that would be this diagram here. Right, which warrants explanation, right? Over the course of chapter 4, we cover section 4.2, 4.3, and 4.4. I'm going to keep coming back to this because it's good to reiterate, right? Another thing in the position of teacher, you must remember, the more you repeat yourself, the better, because repetition is how people remember things, right? Little kids especially, so you got to give them some kind of task, right? What we're responsible for immediately are what you're going to see from here to here. Right? This is basically the amount of what we're going to be talking about today. Right? This is section 4.1. Okay? The ancient systems of numeration, right? Which include, if you're going to categorize them, additive systems, which is a little misleading, that term, but additive systems, you do involve adding. Multiplicative systems, and what I refer to as ciphered systems. There's very subtle distinctions between them, right? Other ancient systems, but we're holding off until, I believe it's section 4.2, would be the positional ancient systems, and it's arguable that Babylonian is not quite right, all right? Anyhow, the Babylonian system and the Mayan system are the other two ancient systems, but they're of the positional category, if you will. All right? So that, to give you a heads up, is section 4.2, I believe. I remind myself. Sorry, got banding on. Yeah. Okay. Yeah. All right. This will be pertaining to section 4.2. All right. Then there are what are referred to as modern positional systems. All right. The system that we use, all right, which is often just referred to as Arabic numeral system, is actually the Hindu Arabic numeral system. Now, we live in Western society here in the United States, and much of our cultural origins are from Europe, all right, or North Africa, all right, the Western hemisphere, all right. Anyhow, the actual concepts though originate from India, right? So hence they are the Hindu Arabic positional systems, right? That I want to say is section 4.3 and 4.4. I don't remember if it's all at once though. And bear with me 1 second. I don't want to misinform you. Okay, this is 4.3, right? Entirely. And then when we apply the, especially binary, octal, and hexadecimal to operations, that would be section 4.4. Okay. And that's another good reason why it is beneficial to have broken this up into several days rather than all at once, right? It's kind of alien. Whenever you're in the position, you guys are going to be teachers naturally, in the position of teacher, whenever you're teaching something that is, truly alien, and I would argue that without getting myself in trouble here, ancient Egyptian hieroglyphics are very foreign to a modern human, all right? I'm not saying anything about aliens, extraterrestrial aliens. I mean alien in the sense of not familiar. Okay, so that's the plan. Immediately, we're going to cover these: Ionic Greek, traditional Chinese, Roman numerals, and Egyptian hieroglyphics today, and then Babylonian and Mayan next week. All right, and then the modern systems. Okay. Now, let's see. How to distinguish these. All right. Let me flash something really quick. All right. This is again an overview. These are diagrams that you would have in your book. So by all means print that because it summarizes clearly, because it's printed. It's not just written by me. What these numbers and symbols translate to. All right. So this is relevant for section 4.1, right, primarily. All right. To reinforce the concepts, though, please look at my worksheets that I've made because I'm hoping that this will make everything a lot clearer, more clear. So you'll see the document that is labeled Facts About Ancient Systems. Oh no, I made it a PowerPoint. Okay. I have to wait for it to load. But I don't really want it. I want the PDF. Command. Yeah, okay. Sorry. These are all my things. I make this just to take the opportunity. You may be inclined to make worksheets in Word, all right, or whatever Google's equivalent is. There's nothing wrong with that, but I have found that if you're going to make a worksheet from scratch, do it in PowerPoint because you won't have to fight with the preset margins and stuff like that, which can be a little bit of a nuisance. Even printing and manipulating the drawings that you make is much easier in PowerPoint than it is in Word, which is why I made it in PowerPoint. Quit. This is what I'm after, the same that I have made as a PDF here. All right. Now, here are the facts about ancient Egyptian hieroglyphics. All right. The order in which the characters are written is not important. All right. You could have, in theory, two different arrangements that can represent the same quantity, which is a little annoying because there's, it's nice to be flexible, but when you stare at something and you recognize it, and then you see that it's not in the same order, you might be a little, reluctant to assume it means the same thing, right? Anyhow, the order is not important, right? It's actually, think about it this way. This is one of the older systems of writing, all right? Either this or ancient Sumerian, which is what Babylonian is derived from, all right? The wedges and boomerang shapes that you see in clay. They seem to have been created almost about the same time, like 3200 BCE, all right? And they're they're very close to each other geographically, but they're different ideas, right? To represent a number, and writing. Anyhow, because it's so old, right? One thing you'll notice as you're analyzing it is that it's not very complicated in terms of math, right? At most, it's really just adding, right? It's mostly adding and what you might call not adding, right? Which we would think of as being subtracting today, but it's not using a symbol. Their idea of subtracting is to simply not write as many characters in sequence, right? It's a sort of quasi form of subtraction. There's also this concept of duplation and mediation, which is for multiplication and division. You are not responsible for that, but if you'd like to, you could read it in your book. It's in section 4.5, I think, right? Another interesting characteristic about them, right? There's no symbol for zero in ancient Egyptian hieroglyphics, right? They do handle fractions interestingly, right? They have reciprocals, right? Remember, a reciprocal is if you had something like 1/3, it would be these two reversing position, 3/1, right? So if you started out with a 3 and you wanted to form the reciprocal of 3, right? And in ancient Egyptian hieroglyphics, they would employ this symbol, which looks, disturbingly like a 0, right, sideways, but it's not, right? And then attach 3 sticks to it, if you will. So if you wanted to form the reciprocal of 3, you would put 3 symbols for 1 underneath this, all right? And that would represent 3 upside down, more or less, which would be 1/3, as opposed to 3/1, right? Now, what they do have also is the use of powers of 10, essentially. All right, powers of 10 being, to be very formal, 10 to the first, 10 to the second, 10 to the third. But what do they equate to? 10, 100,000, things like that. That's why I left this diagram here, because blank, because I wanted to talk about it and sort of more or less walk you through the process. If you give your students a worksheet, especially the best ones are the ones you make yourself, really, right, because you are the author. Keep it simple, all right, and get the ball rolling, all right. Walk them through the process, right. Giving them an activity will keep them engaged, right. If you're just talking at somebody, that's never good, all right. Now, the Hindu-Arabic symbols that we know and love, right, would be something like this. All right, we'll talk about it in terms of powers of 10. The first power of 10 is 10 to the 0, technically, and that is the number 1. Right? 10 to the first is just ordinary 10. 10 to the second is 100, number of zeros. This is essentially the pattern here. 10 to the third is 1,000, 3 zeros. 10 to the fourth is 10,000. Which I'm conforming to the American way of writing this, which is to group things in sets of 3, and then separated by a comma left of the decimal point. Right. 10 to the 5th is 100,000. That's 5 zeros, and then we'll go up to 10 to the 6th for our purposes here, which is 1,000,000. 2 groups of 3 here. Okay. Now, what are the ancient Egyptian symbols that correlate to these Arabic numerals? All right. In sequence. They're interesting. One of them I kind of alluded to already when I was talking about reciprocals. I'll put this in blue for the sake of contrast. There's a symbol that is a simple sort of stick figure like that, which is intuitive, right? A lot of this comes, especially when you get to Roman numerals, you notice that this is something like our hands, right? The most intuitive way to represent a number is literally with our fingers, right? So even the word digit comes from the Latin word for finger, all right? So that's a 1, right? Like your first finger here, right? However, the drawing is thought to be an illustration of a staff, perhaps. All right. So that would be the word associated with that, right? The amount of 10 is this sort of horseshoe shape, right, which is referred to as heel. Now, unless my spelling is incorrect, right, I think they mean a heel as it would look like an impression of your foot on the beach, you know. That's just I'm guessing at that. Don't quote me at that, but that would seem to make sense. Now, why does it equal 10? I don't know specifically. You'd have to ask a linguist about that, but the name for this is from the sort of backwards part of your foot. All right. 100 is represented by this sort of curlicue shape, which is referred to as scroll. Now, I believe the logic there is that it's a rolled up papyrus in profile, so you're seeing the edge of it. All right. Let's see. 1,000 is this shape, which I like a lot. It's called a lotus, as in the flower, but the way that it's drawn is sort of a crescent moon, and then a downward pointing arrow, and then that sort of oval shape. All right, which to me, maybe my memory is a little fuzzy. It kind of reminds me of a fire flower from Mario Brothers. You get that, and then you could throw fireballs. But if you want to draw it yourself by hand, and a lot of times you have to as you're doing these assignments, draw a moon like Lucky Charms. All right, a downward pointing arrow and an oval. All right, 10,000. All right, is the pointing finger, which thankfully is not the middle finger, right? And that's sort of, again, in profile, so it's sort of like that, as if to say, no, 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 you know, pointing finger. Then there's something that looks something like a Jesus fish. It's called Tadpole. And if you were going to draw a Jesus fish, right, it would be something like that. And there's an eye. It's thought to be a fish, or a tadpole, which is, you know, early stages of a frog, right? And the last one is my absolute favorite. Because it's a picture of a little man, all right? Or a little person, right? So you draw a stomach, right, a tummy, if you will, like that, and a little head. And then you put these hands raised like so, and then 2 feet, as if a person were doing this, you know? It's called astonished person. I'm not making that up. That at least is what it says in your book. Astonished figure or astonished person. All right. Now, why does that make me laugh? Because, again, if you think about it in terms of history, right? In modern life, how often do you see this amount of money? You know, it would be great. You know, like if you won the lottery, you'd be a millionaire, right? In theory, you know, unless you played the Jersey Cash 5, in which case it would be less than that. But it's such a foreign amount of money to us, even though we're aware of it. You know, because we don't deal with that quantity of something in ordinary life. Now, imagine if you went back in history when fewer people were literate, you know, whether numerically or verbally, all right? That figure is appropriate, right? Because it's as if they were shocked, you know? I don't know if the more recent, you know, translation of translators of ancient Egyptian hieroglyphics are, you know, throwing in some artistic license here. But it looks like a person with their arm raised as if they were appalled, you know, or really impressed by something, right? As if to say, wow, so much grain, you know, so much money, all right? All right. So why don't we, with this information now, let's try a couple of the examples. Again, that would be the latter pages that you can print out, the stuff that is in green here, right? All right, given the information that we have, which is that I lost my thought. We don't have to worry about the order, all right? We're just going to worry about these characters, okay, and how they're applied. The example, without switching the slide here, because I want to keep the reference, example 1 from the packet would look like this. They would ask you to translate from essentially Egyptian hieroglyphics to Hindu Arabic numerals. That is what we're familiar with. All right. And you will see the following in sequence. This is kind of getting to be a dud. Is that visible? No, it's a little bit out of the frame. So let me back this off just a wee bit. And put my book away. There we go. That's a bit better, right? Okay. If you were going to translate these shapes, which I'm not drawing very well, unfortunately, in sequence, you're just going to add them together as you translate across from left to right. Right. Ancient Egyptian hieroglyphics in blue here. Pointing finger, pointing finger, pointing figure. Scroll and profile, scroll and profile, scroll and profile. Heel, staff, 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 staff. Right? What does that translate to in Hindu Arabic numerals? Right? Well, again, it's an additive system, so you're just going to add them as you go across. It's nice to have them organized that way, but they don't actually have to be. So, if a pointing finger is 10,000, then this is essentially the amount of 10,000 times 3. Right? If a scroll is 100, then rather than put 100 times that, it's times 3. I'm just adding efficiently. You know, multiplying is adding efficiently. All right. Heel is 10, and staff is 4. All right. So it's 1 times 4, if you will. All right. What does that make? 10,000 plus 10,000 plus 10,000 is 30,000. Naturally, right? 100 plus 100 plus 100 is 300. This thing is falling asleep on me. Don't do that. Come on. Sorry. That is 10. And 4 times 1 plus 1 plus 1 plus 1 is 4. Right? So the Hindu Arabic number would be these amounts added. Right? 30,000 plus 300 plus 10 plus 4. So 30,314 is what it would equate to. Okay. Again, if I were doing this really as a stickler, all right, I wouldn't involve multiplication at all, because this is so, you know, before multiplication in the classic sense, right? It's an additive system, so you literally just add what you see, right? And again, since there isn't really formal subtraction as we think about, if they were going to subtract, they would just not write something, you know. They wouldn't write as many symbols in sequence. Okay, let's do another. I'll try to use a more contrasting color here. This blue is giving up on me. If you look at example 2, let's see. We're going to go the other way. So we're going to translate from Hindu Arabic, right, to ancient Egyptian hieroglyphics, which is fun, right? It's like we have our own secret code now. Not really secret though. So if we had the quantity 1 million, comma 203,000, comma 462. All right. Do we have a symbol for a million? We do. All right. So, and it's just 1 million. So we only need one astonished person to represent that much. There's this sort of blimpy looking dude here who's very happy because he has a lot of grin. All right. And then we go over to the 100,000s place value here, where the 2 is sitting. We have a symbol for 100,000, that power of 10, which is tadpoles. But since it's 200,000, all right, it would be Jesus fish, if you will. Tadpole, tadpole. In sequence, all right? There isn't anything in the 10,000 category, it's just 0. So if you look where the 3 is next, we have the thousands place. We have a symbol for 1,000, which is the lotus flower, right? Which would be crescent moon, crescent moon, crescent moon, downward pointing arrow, downward pointing arrow, downward pointing arrow, and the pot, if you will, if they're sitting in one, right? All right. Astonished man, person, dude, whatever. Tadpole, tadpole, lotus, 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 right? Next is the hundreds place. There's 400 there, so we're going to need 4 of the symbol that is scroll. Scroll, 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 scroll. All right, and then there's a 60. So we're going to need 6 of the 10 category, which is heal, 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 heal. And then 2 in the ones place, so 2 stabs, if you will. Okay. So all together in sequence, you can see how this is easy to deal with, all right? And that's probably why it came into being, because it's very intuitive, right? If you have a larger quantity, you have more stuff to write. But it isn't efficient. That's why our Hindu-Arabic system that we use today is a better system, at least insofar as writing it. All right, astonished person, 2 tadpoles, 3 lotuses, 4 scrolls, 6 heels, and 2 stabs. All right, and that's the answer. All right, for that, this is from the last question. Don't confuse that. I think there's another one before we shift gears here. Let's see. I guess that's it. Okay. All right. Let's get into the next system, which is also additive. All right. The Roman system. All right. Roman numerals. If you're like me and you went to Catholic school at some point, you might already be familiar with this, but maybe you're rusty. So we'll go through it. Ancient systems continuing here. All right. What I put up here are the symbols that you are inclined to see. This is the set, if you will, if you're going to put them in fancy braces. Roman numeral I, V, X. All right. Less used, perhaps. Roman numeral L, C, D, and M. Okay. And there is also a bar notation if you have larger things than that. Anyhow, here are the fun facts about this before we try some examples. In this case, they had some distinction from ancient Egyptian hieroglyphics. All right, ancient Egyptian hieroglyphics, the order is not important. Roman numerals, the order is very much important because it will ultimately decide whether you're adding really, it's an additive system, right, or subtracting. All right, it is for the most part adding. That's what you'll see. All right. But there is a more formal way of subtracting by actually writing the symbols involved. Just change the orientation of them. All right. In Egyptian, remember, as far as we know, ancient Egyptian hieroglyphics, to simply not want to have it, if you want a smaller quantity, you would just write fewer characters. All right. There is again, though, no symbol for 0, right? The Romans would have thought about it this way, right? If 0 in the classic sense is that it represents the concept of nothing, why would you need a symbol to represent that, right? Well, in our decimal system, it really is imperative. All right, the development of 0 historically is from, I think it's Brahmagupta from India, if I'm not mistaken. A little bit later in history. It's a revolution in thought. To have the symbol for 0 and then to have a decimal system is so much better than what we had previously. All right, it's more efficient. Right. There are some rules. Right. No more than 3 of the same symbol in sequence. Right, in a row. Right. In other words, you can't. You will, if you need a bigger quantity, you will use more V's, more X's, more I's. Right, but the limit is 3. Right. Can't do 4 X's in a row, you can't do 5 X's in a row. Right? And you read left to right. The trick to this is really to look for coupling of characters in sequence. I put a little diagram underneath this, which I will explain. Right? How do you decide whether you're adding or subtracting? Right? Well, if you saw a V in the front and an I after it, right, versus if you saw an I in the front and a V after it, right? Think about it this way. If this is really, V is a 5, all right, and I is 1, the left figure is bigger, greater than the right figure. And in that case, you actually do the adding. So 5 essentially plus 1 is 6. All right. If you had this situation, the orientation reversed, all right, then the figure on the left would be 1, and the figure on the right would still be 5, but this would be less than this figure, right? Now, we are aware of a slightly more complicated form of math in which there are negatives. There are no negatives in Roman numerals, all right? The concept of negatives, I wouldn't say occurs until maybe the Middle Ages, all right? So this predates that, all right? We don't write things backwards like this when we mean 5 minus 1, because we're trying to avoid the issue of getting a negative 4, you know. Anyhow, it may be arranged this way, and that's how it translates, but you really do the arithmetic like that, all right? The larger quantity in the front, on the left, and then minus, all right, which makes this actual subtraction, and then you have a 4 instead of a 6, okay? What I should do, although you have the table here, is just go back up the page to remind you. All right, here are the characters from swipe from the book, what they translate to. All right, if you need them. All right, I'm going to scroll up the page in a moment and just sort of label them for reference. All right, now last thing here, as a fun fact about Roman numerals. For quantities that are greater than 1,000, the letter M represents 1,000. But if you have, something beyond 3,000, which would be 3 M's in sequence, right? You can use bar notation. I really should have added that. All right. A line above a group implies that you're multiplying by 1,000. Okay. So, having said that, let me just go up here and remind you of what these translate to. All right. This is 1, to make it rather stylized. This is a 5, and this is a 10. All right. L is 50. C is 100. D is 500, and M is 1,000. Now, I would argue that the logic, at least earlier on, works something like this, right? If you analyze a lot of different ancient systems, they always have a sort of a stick figure like that, which intuitively represents the amount of 1, like your finger, right? If you want to extrapolate on that, I really can't say for sure, but I would guess that the reason that they went with the 5 as being a V is because that's kind of the outline of your hand, all right? That's just me speculating, though, all right? So if it helps you remember what they translate to, then say, yeah, one I as in a finger and a V as in a 5, you know, tubular. All right. And what is an X really but a V sitting on top of a V? So 5 and 5 is 10, right? L is 50. I'm not really sure what the reason is. If you look into the history of the Roman legions, all right, perhaps there was there's some similarity there. All right. C is 100. I can tell you as a person who once studied Latin that and Italian that the translation of 100 is cento, right? Which starts with the letter C, and that should be intuitive to us Americans, right? Because in a dollar, how many cents are there? 100, right? Total, right? D is 500, M is 1,000, which kind of makes sense if you know anything about the metric system, right? Like milli is 1,000. Okay. So be aware of these translations, and we'll now do some problems. If you look at example 3, which for some reason I didn't write, oh here it is. Okay, we're going to translate from Roman numerals to Hindu-Arabic numerals. All right, what we have here. I'll make that red, because it's kind of a Roman color. And then we'll do this. All right. In sequence, M, capital M, D, C, C, L, X, X, V, I. All right. This is a quantity in Roman numerals. All right, we're going to translate it to more or less the regular way of looking at something. Hindu-Arabic numerals, the better system. All right. Now, do try to get in the habit of looking at things in pairs, all right, and then comparing them, because again, that will decide whether you're really adding or subtracting. All right. So, to set a good example, let me try that first here. All right. If you were to compare these two, M is 1,000 and D is 500. So more or less, the situation is that the greater quantity is where it ought to be on the left of the symbol, the left side, if you will, of the pair. So we're really going to add them. That makes this 1,000, all right, plus 500. All right, still an additive system, right? All right, then we could move on. All right, and you see these two in sequence. They're the same exact quantity, the same numeral, CC, all right? So if C represents 100, that'll be 100, plus another 100, all right? And then we have another pair here, all right, which is 50. So again, it's the greater quantity on the left, so we're going to really add these, which is 50 plus 10. All right. And then another quantity here, still adding, all right, because the larger quantity is on the left, which is 10 plus another 5, all right, and then we have leftover 1 here. So if you add these all together, what would you get? All right, 1,500, 600, 700, 1,700, 50, 60, 70, and then 5 plus 1 is 6. So birth date of the country, 1776, United States. All right. Okay. Once you do this a lot, you can probably get at it more efficiently than you see me illustrating here, but this is a system that would work. Look at things in pairs and you'll get to the same answer regardless. All right. All right. Let's take a look at example 4. In which case we're going to translate it backwards. erased a bit more than I would have liked to, but it's okay. Maybe it's a good quiz. All right. If we're going to translate from now Hindu Arabic numerals into Roman numerals, all right, you have to remember, we're not allowed to use more than 3 of the same Roman numeral in sequence, right? And if we want to subtract something at all, we're going to have to change the orientation of the letters in pairs, right? So if we are given, oh, I'm sorry, we're still doing it the other way. I'm looking at the wrong thing. Yeah. We're still doing it straight Roman, sorry, to Hindu Arabic, so let's continue with that before anything else. All right, if you see CM LX IV. Okay, we'll translate this into regular characters. Okay. Again, read things in pairs. All right. The C is indicative of 100, right? And M is 1,000. So based upon this orientation of the smaller quantity on the left side, we're going to actually subtract them. Essentially, it's 1,000 minus 100, right? Which would make this 900 by itself. Okay. Move over to the next two. All right. That's a 50. And that's a 10. All right, I'll put it here just to keep it out of trouble. And that's the normal orientation, the larger quantity on the left. So we're just going to add them, all right? So it's 50 plus 10, which is 60. It's a little bit faster than before. All right, and then we have these two. All right, we have that situation where we have a 1 and we have a 5, but the smaller quantity is on the left, so we're going to actually subtract. It is essentially 1 minus 5, which makes this 4. Right? And therefore, the quantity in totality would be those things nonetheless added after the subtraction has occurred, 964. Okay? All right. Now example 5 is the other way. Sorry to jump the gun like that. Translate from Hindu Arabic to Roman numerals. Yeah, so if we were given the quantity 439, all right, just a couple of reminders, all right? We're going to be mostly adding here, all right, some subtraction if we change the orientation. We're not going to have a symbol for 0, and we're going to use no more than 3 of the same symbol in sequence, right, in a row, left to right. All right. So right away we're going to get in trouble with that, right? Because look, we have something in the hundreds place, we have something in the tens place, and we have something in the ones place. If you analyze the hundreds place, all right, we have a quantity that exceeds the maximum of 300, right? So we can't write C, 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 even though we'd like to. That would be simulating ancient Egyptian hieroglyphics when they had no limit. You could do it as many as you like, all right? For the formality of Roman numerals, we can't go about the process. That's too much. So what we have to do is subtract instead. My thing is falling asleep. Sorry. Wake up, please. There you go. What do we have? Let's see. All right. We have another symbol just above that, which is 500. This is 100, right? This is 500. So what we're going to have to do is to represent the concept of 400, all right, we're going to have to subtract from 500. we're going to really need 500 minus 100 to accomplish that. Now 500 would be the letter D, and 100 would be the letter C, all right? But in order to get it to actually do this, we have to reverse the position of these. So that goes in the front and this comes after it. That means that what we're going to get is CD rather than DC, right? If you want to effect subtraction, that is the proper arrangement, the smaller quantity on the left, okay? Just don't put the little less than symbol there, right? Right. This causes subtraction, more or less. Okay, now next thing over here is we have something in the tens place, which is 3. That's fine, we don't worry about that. We could just do these letters for 10 quantities in sequence, which is x, x, x to accomplish 30. And then we have 9, all right? Now we get in trouble again, all right? Because we can't put 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 9 ones, all right? We can't do 1, 1, 1, 1, 1, 1, 1, 1, 1, right? We have to subtract instead. It's exceeding the maximum. So we're very close. You're at the precipice of just being 10, right? So in a situation like this, you'd have to do 10 minus 1 to accomplish 9, right? But in order to cause subtraction to occur, you have to change the position of these to 1 minus 10, even though that would be counterintuitive to us modern people who are familiar with negatives, right? Anyhow, the symbol for 1, I'm sorry, I'm drawing on my own writing here. We're going to write it like this, 1 minus 10 instead. The symbol for 1 is intuitively I, and the symbol for 10 is somewhat intuitively X. So that's what we should have. All right, CD, X, 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 I, X, okay, as the translation for 439 into Roman numerals, okay? All right, one more of these and then we'll shift gears. Number 6. Pardon me, that was number 5, so yes, we're going to do 6 now. I just didn't change it here. We're going to translate 12,345 into Roman numerals. The Hindu Arabic $12,345 into Roman numerals. All right, now what we have to bear in mind in a situation like this is that, remember, for quantities that are greater than 1,000, I really should annotate this. Greater than 3,000, so something like 4,000, all right, where we can't put 4 M's in sequence, we're going to use bar notation in a situation like that, all right? By quantity, I meant powers, you know, of 10. Anyhow, take a look at this. All right. This figure up here, what is 12,000, is far exceeding the symbol that we have for 1,000. Right? We can't put 12 M's in sequence. All right. So what we're going to have to do is figure out something that equates to 12 and then multiply by 1,000, right? Using bar notation. All right, we're going to put a bar over whatever those symbols are. Okay? So can we just simply write the number 12, right? We can, right? If you're going to write the number 12, we can use an X and then 2 I's. All right? And then to represent this idea of multiplying by 1,000, I'm just going to get this schmutz out of the way and not make it confusing. We're going to put a bar above these two, like that. They're in a group, the way that I've written them in parentheses is, but when we write them in formal Roman, if you will, we're going to write it like that. Okay. A bar above these to represent this concept, right, of being times 1,000. So it's 12 times 1,000, if you will. All right. Now for the rest of it, we can pretty much go about our business. Right, we have over here in the hundreds place just 3, so we could use, and we have a symbol for 100, so we're just going to use 3 C's, C, 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 and then we have 45. Right, we have 40. If we were going to do 40 again, we'd get in trouble, right? Because we would have, we can't put 4 X's in sequence, right? But we can subtract from 50 because we have a symbol for 50. So, so just paying attention to this, we're going to do essentially 50 minus 10 to represent 40. I know it might be, you might jump the gun and go straight for 45, but be careful, all right? And then we have to write them in more or less this backwards arrangement. So even though we think of it as being 50 minus 10 in modern math, right, we have to think about it like Romans. It would be essentially like that. So the symbol for 10 is X, the symbol for 50 is L, and this much would be 40, right? And then there's the last bit of this, which is just 5, which we have a symbol for, right, which is V, right? So in essence, I'm going to put this in green just to sort of annotate. X11 is 12 times 1,000 to make 12,000. CCC is 300, right? These two in sequence are 40, and that's 5. Okay. You might be wondering, I mean, like, why don't you just put the V behind this, right? And I get the shortest explanation I can come up with is that it would seem to be more efficient to just simply do 50 minus 5, right, to make 45. But we're neglecting place value, right, in the process. Right, so even though that would seem to be a little bit shorter, and I agree with that, all right, in theory, all right, if I wouldn't jump the gun by going to that small of a unit, 5, when I could just simply use a 10 first, all right. I'm sure at some point in history, Romans debated that themselves. We are not alone. Okay. All right. Now, we've gone through ancient Egyptian hieroglyphics and Roman numerals. Now let's look at traditional Chinese characters, which are very beautiful, actually. They're the kind of thing that you would need a paintbrush really to really do the justice they deserve. All right, but here's some fun facts about them. All right, traditional Chinese characters. All right. Now, these are similar to Hindu Arabic numerals in that we have characters for 0 through 9. All right. Again, if you want, there is this overview, and These are probably stylized a little bit the way that you see them printed in our book, right? But here's your best reference. I'm going to attempt to draw them, but I have lack of experience is not going to make them pretty, all right? And I'm using the wrong tool, all right? If you were going to do these, as I said, any justice, you would probably do this with a paintbrush, all right? So do beware of that, and please forgive my lack of artistry. All right. Anyhow, there is a character symbol for everything from 0 through 9. So they do include 0, which is very useful. All right, in sequence with a power of 10. This is called the multiplicative system. All right. Remember the systems, just to flash this really quickly. I'm going to just minimize this for a moment because I want to just point to something. Here's an overview of systems again, right? We have discussed the two additive systems of interest to us right now, and now we're going to go with the one multiplicative system that we're going to use. All right, so additive systems are adding essentially, right? And subtracting in the more formal sense when we get to Roman numerals. But the multiplicative systems, which are adding efficiently, right? This is going to involve adding, addition. This is going to involve multiplication, obviously. But what is multiplication but just adding in an efficient fashion, right? So it's going to be adding also, adding by default. Okay. We'll just refer to it as multiplicative because it's better to multiply when you can. All right. All right. Now moving on. You're going to be multiplying a lot and then adding by default, right? There is a symbol for 0, right? I alluded to that already, but it looks like this. To me, it looks like a person's face, right? I don't want to do it an injustice by saying that, but if you're trying to draw it yourself, and I have had to many times, right? Convince yourself that it looks like something familiar, right? 2 eyes, a little nose, and a mouth, and a chin, right? So sort of a person if they were wearing a lot of makeup, right? Almost like, what are they, that's Japanese culture, but kabuki style of painting, I think. Anyhow, it's referred to as ling, right? If you went to China nowadays, if I'm not mistaken, they don't use this anymore, but maybe for, just for cultural reverence, right? This would come up at some point, right? Now, quantities are written essentially in pairs again, but they're going to be written vertically, which might be a little odd to a Westerner. All right. So what you'll see is essentially something on top, the character representing 1 through 9 on top, and then immediately underneath it, there'll be some power of 10 that you multiply by. All right. The ones, or what the book refers to as the units place, are never multiplied, right? You just have the whatever symbol that needs to be there. It's understood as being the very bottom row is the ones units, all right? For things between 11 and 19, all right, you're going to basically just write the character for 10, all right, and then the additional character for 1 and 9. All right. Okay. All right, you'll see what I mean when we get there. If you're worried about any zeros between, all right, like if you had a Hindu-Arabic number like 1002, 1002, you wouldn't have to put 2 symbols for 0 in between. 1 is sufficient, all right? If you have a 0 that a number ends with a 0 on the very far right, you don't even have to bother writing the ling symbol. Okay. All right. Now, again, just for reference, all right, keep this handy. All right, the character symbols and what they translate to. Notice that they have symbols for 1 to 0, 0 to 9, and then these powers of 10 is what we're going to discuss. Okay. let's do some examples. I'll just simply draw it up here. Example 7. All right, we're going to translate what is Hindu Arabic into traditional Chinese characters. Okay, so remember, basically we're going to follow this model, all right, of the character on top times whatever power of 10 underneath it. That's the general idea. I'll write the Hindu Arabic in blue and the Chinese character in red just to make them distinct. Red seems like it would be a more appropriate character for Chinese, right? Because it's like, you know, when you go to a wedding. You know. All right. I'm not mentioning communism. I was like, that's a whole other ball of wax. I'm thinking wedding dresses are red. You know. Anyhow. If we had the figure, the quantity 538. All right. Let's translate that into pairs that represent these parts. All right. So you might start out with, I'm going to put this over, I'm going to rewrite this here, 538, and then I'm going to break it up into something on top, something on bottom, for each of these places. All right. All right. Except when we get to the units, then you don't have to do that. All right. So we would have 500 on top. All right, just to give you some scaffolding. All right, and then 30 in the middle here, and then 8 underneath. All right. This is going to be broken up into 2 pieces, and this will be broken up into 2 pieces. This is just whatever it is, because it's the units placed, ones placed. It's never multiplied by anything. All right. All right. Is there a symbol, if you look at them, for 500? There isn't, right? Because they use powers of 10 that are 10, 100, 1,000. All right. But there is a symbol for 100. All right. So we're going to use that, and then we're going to multiply by the equivalent of 5 to make 500. All right, which means, all right, we're going to have to think about it this way. 5 times 100. I know that this is kind of upside down compared to what we're used to. Usually we have the larger quantity written on top, but we're translating it into characters. All right, so there is a symbol for 5. All right, which I'll put in red, and forgive me for not drawing it really correctly. Again, I should be using paintbrushes for this. So 5, and then the multiplier of 100, right? Maybe I had some distinction. I'll put this in green because it's similar to red. The symbol for 100 looks something like this. Okay. I'm just going to keep this sort of scaffolding for a moment, and then I'll erase it to make it look a little bit better. All right. Now for 30, right? It's going to be 3 times a power of 10, which in this case is actual 10 itself. All right, 3 times 10 is 30. What is the symbol for 3? That is intuitive. You know what? Think about it this way. Roman numerals, vertical finger, all right, for 1 and 2 and for 3. Ancient Egyptian hieroglyphics, all right, the staff symbol is more or less a finger shape, right? 1, it's vertical. In traditional Chinese, it's the same idea. It's just what we would regard as sideways, but it's just oriented horizontal. 1, 2, 3 is very intuitive. A finger, 2 fingers, 3 fingers. So 1, 2, 3. Right. Just goes to show math is a very intuitive human thing. Right. So I'm not doing it any justice. Right, but that's 3 with my markers here, but that's 3. And then what are we multiplying by? The symbol for 10, which is similar to sort of a cross shape. Forgive me. Again, I'm going to put this in green just to make the multiplier obvious. Okay. So the symbol for 5 times its multiplier for 100. The symbol for 3 times its multiplier for 10. All right. And then this is still just 8 because it's in the ones place. All right. When you get to, again, the units place, there's nothing to have to multiply by because the character already exists. All right. So the symbol for 8, to me, kind of looks something like a mustache. So, but it might be stylized a little bit better than this. Okay, and rather than horizontal, the whole thing is vertical. So it's a math problem, right? I'm going to remove my little skeleton here so that you can see it. All right. This would be written vertically. Yeah, that's pretty, isn't it? All right. Let's get into this stuff down here. Look at example 8, which has 2 parts. It has to do with the zeros. Maybe just to complete this thought. Shoot. I don't want to neglect to mention something if I can help it. Okay. I'm just to complete this thought, because I did allude to that, right? If you had just the number 19 or the number just 11, that is the things that exist between here and here, right? You're not going to involve multiplication, right? You are still going to write things vertically, but what you would do is you would write the character for 10, and then, we'll do one of these at least, right? For 11, right, it's just going to be 10 plus something, right? For something like 19, it's just going to be 10 plus something. Right. Because if you think about it in the larger sort of scheme, right, the very bottom is always the character that would be within the ones place, which would be either the number 1, all right, or the number 9, as in this case, all right. So no multiplication really, all right, but the character symbol for 10 is still sort of that cross shape. I'm trying to simulate brush stroke. And then the symbol for 1 is just a horizontal stroke, like that. So it's 10 plus 1, right? No multiplication. That's 11. If you had 19, it's a very similar idea. I'll put this in green. It's still that brush stroke that looks like a cross this way. And then the character for 9 which is more like this. Kind of almost looks like a pi symbol, right? Something like that. Okay, so 10 plus 1, 11. 10 plus 9, 19. If you had 18, a different symbol here. If you had 17, a different symbol here. All right. Now let's do the thing, discuss the situation with the zeros. We just did example 7 a moment ago, so we'll do 8 now. And 8 has 2 parts. Right, so 8. We're going to translate Hindu Arabic into traditional Chinese. Bearing in mind the situation with zeros. Right. So for part A, right, if you will, we have this figure, 7,080, and over here for part B, we have a situation where there are zeros in between, 7,008, that's a 7 as well. Okay. Again, start with the character, pardon me, the number 7,080, and then break it up into places, right? So you would have 7,000. In theory, you would have nothing 100, and then you would have 80, and then you would have nothing in the 0 place, right? Written vertically in our system, it would be something like that, all right? And then, just for contrast, think of these each as then having to be broken up into individual products, right, except for down here, right? So 7,000 would be 7 times 1,000, right? In theory, if we were sticking with the program, and you'll see where this deviates slightly, if it were 100, it would be 1 times 100. But it's going to be 0 essentially times 100 in that part. And then 80 would be 8 times 10. And then 0 is just 0 because it's in the ones place. All right. Now, a couple of things to bear in mind, right? If we have a 0 on the far right as we have here, you don't have to draw the symbol for 0 in this position. It's not necessary, right? So you could actually exclude that right off the bat if you feel like it. That thing is becoming a dud here. But let's continue with this. I need the space, so I'll put this back later. The character symbol for 7 is sort of a tau shape, something like that. The character symbol for 7 looks something like this. 1,000 is more sort of a stylized cross again. bit more flair. 0, when we have zeros between, you just have to put 1 in between. Right? And you don't even need to include the multiplier, even though it would for any other figure. 0 is just 0. So this is why I say Ling kind of looks something like a face to me. If you're trying to do it the first time yourself, all right, not to corrupt your opinion, but you might think about it as you would a face. A person wearing a lot of makeup. Okay. And then 8, symbol for 8, is again sort of a mustache shape, if you will. Times 10, simple cross shape. And then we don't need to put a Ling down here. So we have 7 times 1,000 as a couple. Ling is sufficient. You don't have to put 0 times 100 if it's in the middle. Just 1 0 is sufficient. All right. And then 8 times 10. And then no Ling because it's in the ones place. And that would be the whole thing. Okay. One more of these and then we'll switch over to Ionic Greek. Not ironic, Ionic. B was, what B was 7,008. Right. So, again, I write them sort of stretched out across the page. Break it up into pairs vertically. I'm sorry I'm drawing on my own writing, but I prefer to have it as a quick reference, even for my own sake. You have 7,000. Then there's nothing really in the hundreds place, and nothing in the tens place either. And then there's just 8 down at the bottom, the ones place. All right. 7,000, we're going to do exactly what we had. It's 7 times 1,000. There is, we've already discussed, no reason to do 0 times 100. It's unnecessary. Right? There would also be no reason to do 0 times 10. See, I'm so boring, I put my computer to sleep. And then 8 is just 8. So if we translate these, sort of a tower shape again, and it's got to be curved. You don't want to confuse it with the symbol for 10, just straighter. Times 1,000. Now, we have double zeros in between, right? We already ruled out that we don't have to put the multiplier in either case when we have 0. But, do we have to put Ling and then Ling again in sequence? You don't, all right? If it's 2 zeros in between for the hundreds place and the tens place respectively, then it's sufficient to simply do one example of Ling. Right, and then the symbol for 8, which is fake mustache, because it's not really a mustache. Okay. So 7 times 1,000. One example of Ling for both of these places, that would be zeros in Arabic numerals, Hindu Arabic numerals, and then 8 in sequence. Okay, and it would look something like that. All right. The last thing is Ionic Greek. All right. For Ionic Greek, here are some fun facts about them. Right. Ionic Greek is like from 1000 BCE. Oh, I just got a shock. Right. It's referred to as the ciphered system. If we did two additive systems, ancient Egyptian hieroglyphic and Roman numerals, and then traditional Chinese was the multiplicative example. This is the ciphered system. These are letters, just similar to the Romans in that respect, used to represent numbers instead of having unique symbols for the numbers. Like in our modern languages that we use, right? We have a unique set of characters to represent numbers, right? Numerals, all right? We don't use letters A, B, and C, all right? Unless you wanted to make a code, right? If you will. That's why it's ciphered, right? There are 27 total. That means that there's 24, and then there's 3 symbols that are now obsolete. It's mostly adding, but it can also be multiplying, right? There's something called a superscript, right, which is a slightly smaller font, a little bit higher, using the iota letter, right, in front to multiply times 1,000. Remember, in Roman numerals, use bar notation over the pair, or whatever group of letters, to represent times 1,000, right? There's still no symbol for 0, right, in the Western world here, but there are symbols for 1 through 10, right? Multiples of 10 and then multiples of 100 up to 900. That's why this is, although a little bit, it's efficient if you memorize everything, but if you look at this, here's the table that you would need, right? It's quite a lot to have to memorize, right? 1 is alpha, 2 is beta, 3 is gamma, right? And you would need to know these names as well, all right? But they have symbols for, again, 1 to 10, then the multiples of 10, meaning 10, 20, 30, 40, right? And then multiples of 100, meaning 100, 200, 300, all the way up to 900. If you wanted, again, something larger than 900, namely, greater than 1,000, you use iota superscripts, right? To distinguish from actual words, a sort of apostrophe would have been used, right? All right, now, that's as much as you need to know, aside from having the character set on hand. All right, so keep this table close to you while you're doing your homework, especially. And we'll do these last 2 examples. Okay, it's just number 9 and number 10. All right. We're going to do example 9, and we're going to translate Ionic Greek into Hindu Arabic. So, if you are given what is the actual tau symbol, in sequence with the pi symbol, and then epsilon, which is sort of like a moon, if you will. You would need the ciphered table that is your code-breaking table, right, to do this, right? It turns out that tau represents the number 300, right? And that pi represents 80. Right, and that epsilon is 5. Right. Then you just add them. It's mostly adding in this case. So we end up with 385. All Right, not too bad, right? If on the other hand, you were going to go the other way, from Hindu Arabic to Ionic Greek, starting with this figure, 1654, we may have to use an iota superscript here, all right? Okay, so let's break this up into pieces first, all right? We have 1,000, we have 600, we have 50, and we have 4, right? There's going to be a symbol for 4, a symbol for 50, believe it or not, and a symbol for 600. But we're exceeding the limit of 900, so we're going to have to use an iota superscript, all right, to get this, all right? So what shall we use? Well, if you were to take this and make it something times 1,000, right? What number times 1,000 would be 1,000? I know it sounds kind of like a silly question to ask, but I mean it, right? That something would just simply be 1, right? Would be 1 times 1,000. So, what is the symbol that is available to represent 1? It's alpha, right? But we have to use an iota superscript in front of it to mean that it's going to be times 1,000. It's 1 times 1,000. What is iota superscript? It's this curved sort of brush stroke in the front. Okay? That's the first part. Now for 600, it's, I believe, chi. Yeah. Which is the original X, if you will. X, all right, chi, C-H-I. Rho chi is a Roman thing, Catholic thing. Probably Eastern Orthodox as well. 50 is nu, I believe. No, it's upsilon, I'm sorry. 50 is upsilon. We're all becoming very good at this, aren't we, right, with the COVID variants running about. Nu is very similar to upsilon in its appearance. It's just, it's less sharp. It's more of a curve, the upsilon symbol to represent 50. And then 4 is, I believe, delta. All right, so delta. All right. So alpha chi upsilon delta with an iota superscript. Superscript, remember, is just a smaller font, a little bit higher, like E equals MC squared. The 2 is in superscript. All right, up in the front of alpha. Okay. And that would be all that she wrote. Okay. All right. I believe that is it. And we'll move on to Babylonian and Mayan next week. All right. All right. Thank you guys for listening. All right. If you're okay with this, all right, please get started in my lab working on section 4.1, and you'll be right where you belong. Okay. I'll see you again on Monday. All right, be careful out there.